Hello, everyone, and welcome to today's Tech Talk in our Business Process Excellence series. Today's session is Transforming Business Processes with an Agentic Mindset for Azure and Fabric. My name is Rachel Profitt, and I will be moderating and presenting today. This session is being recorded on behalf of the Microsoft Corporation. If you do not consent to being part of a recorded session, please disconnect your line. We encourage you to use the Q&A panel at any time to ask questions regarding content or to request support. We will be answering questions throughout and at the end of the presentation. At the end of the session, please don't forget to respond to the survey. We appreciate your feedback, and we use this information to improve future events. Presenting for us today from the Microsoft Corporation, we have Mandi Toves. Mandi, over to you.
Thanks, Rachel. All right, I'm just going to show your slide as well, and then we'll jump in. Okay, today's agenda is not about product features or implementation steps. It's about understanding the process foundation Microsoft uses to drive consistent, scalable implementations and how you can leverage it. If you've been to our previous sessions on CE and F&O, they're very similar to what we'll cover today, just focused on Azure and Fabric. All right, in today's rapidly evolving business landscape, the role of the business analyst has significantly expanded beyond documenting requirements or mapping existing workflows. A modern business analyst must think holistically in terms of end-to-end processes, focusing on the broader flow of work rather than isolated tasks. This includes identifying key handoffs between roles, pinpointing delays, and understanding where decisions are made or where they should be made. By separating work, decisions, and data, analysts can uncover inefficiencies, redundancy, and misalignment across systems and teams. A critical shift in mindset is designing for progressive maturity, beginning with clarity, advancing to efficiency, and then layering intelligence, and finally reaching autonomy. With the rise of AI and agents, analysts must also determine where human judgment remains essential versus where it can be augmented or replaced by automated systems. Ultimately, the modern business analyst is not just a documentarian, but a transformation leader. Someone who orchestrates how work gets done across people, systems, and intelligent agents. This capability is essential to ensure that organizations do not simply digitize inefficient processes, but instead fundamentally redesign them for scalability, adaptability, and measurable business value. Before we walk the pillars, let's reset one assumption. Business processes aren't just finance and customer service. The IT department and the technical processes we follow are business processes too, and they're just as important to get right. In the catalog, that technical work lives under administer to operate. This is true for our customers, and it's true for us. Much of what we do as partners, implementation, provisioning, security, support, continuity, all falls under administer to operate. It's also where you'll find our entire Success by Design framework. That's why Pillar 1, Process Foundation, applies everywhere. Understand and redesign before you automate, because you can't automate what you don't understand. And the maturity journey is the same whether it's a finance close or a cloud operation. Augmentation assists decisions and validation. Orchestration coordinates across systems and removes handoffs, and autonomous operations trigger, predict, and optimize on their own. So apply this lens to the technical processes, not just the front office. Then look for where AI adds the most value first. And if you've been to any of our presentations, you know we continue to say you cannot automate a process you don't understand. We've laid out the pillars. Now the question becomes, how do you prove this is working? That's what this framework is for. 7 categories, each measuring a different dimension of agentic value. With productivity, the most intuitive one. Are we saving time? Are tasks getting done faster? Track time per task, throughput, and automation rate. Quality asks, is the output better? Are there fewer errors and higher first-time right rates? Is there less rework? Efficiency is about speed, cycle times, SLA compliance. Are we moving faster end to end? Experience allows us to capture the human side. Are customers and employees happier? CSAT and employee satisfaction will tell us that story. Adoption is one people often miss. Are teams actually using the agents? And when they do, are they trusting the output or overriding it constantly? Financial impact, of course, ties to the bottom line. We look at the cost per transaction, the revenue lift, and this is what leadership really wants to see, so it's important to measure. And finally, risk and compliance. Are we maintaining control? Audit compliance rates and exception tracking ensure you're not trading speed for risk. The key takeaway here, you don't need all 7 on day 1. Pick the 2 or 3 that matter most to your stakeholders and build from there. Now let's look at how to identify specific process signals where AI can add the most value. Identifying where AI can add value begins with recognizing specific signals within business processes that indicate inefficiency or risk. Common indicators include rework loops, where tasks are repeatedly corrected, manual data re-entry across systems, which increases the likelihood of errors, long approval cycles that slow down decision-making, and inconsistent decisions driven by subjective judgment or lack of standardized criteria. Another major signal is reliance on emails or informal communication channels, which often leads to a lack of traceability and accountability. Additionally, processes that depend heavily on tribal knowledge, information known only to certain individuals, pose risks to scalability and continuity. Once these signals are identified, they can be mapped to appropriate technological interventions. For instance, repetitive tasks can be automated using workflow tools, while decision bottlenecks can be addressed with AI-driven agents that provide recommendations or execute predefined actions. Understanding these patterns allows organizations to prioritize improvements that deliver the highest value. Importantly, AI should not be viewed as a blanket solution, but as a targeted enhancement that addresses specific process weaknesses, ensuring that improvements are both meaningful and sustainable. Okay, this table gives you a consolidated at-a-glance view of the 7 metric categories we use to measure agentic value. Think of it as your measurement cheat sheet. Now, we talked about all of these in the previous slide, but just looking at this, each row maps a category to what it measures and gives you specific metrics you can start tracking today. The left column tells you the what, and the middle column tells you the why. The right column tells you how. Productivity and efficiency are typically where organizations start because the ROI is easiest to quantify. We look at the time saved, we talk about the tasks automated, and the cycle times reduced. Quality and experience are where you're proving that speed isn't coming at the cost of the accuracy or customer satisfaction. These metrics are keeping us honest. Adoption is your leading indicator. If people aren't using agents or consistently overriding them, you have a trust problem, not a technology problem. And as we talked about, financial impact is your executive summary metric, the one that gets budget approval and executive sponsorship. Again, as we talked about before, our recommendation is to pick 2 or 3 categories that align with your stakeholders' priorities. Establish baselines before deploying agents and measure the delta. That's how you build the business case for scaling agentic capabilities across the organization. All right, now we're going to jump into diagnosis. We've talked about transformation pillars and how to measure value. We're going to get into the diagnostic side of things. Because before you can fix anything, you need to know what's actually broken. This is the root cause analysis framework, and it works across 4 dimensions that you see in the slide: people, process, data, and technology. Think of it as a diagnostic lens. On the people side, you're looking at things like skills gaps, change resistance, and unclear ownership. Do they have the training they need? Are the right people in the right roles? Process is about efficiency, consistency, and workflow integrity. Are there steps missing? Are different teams doing the same thing in completely different ways? Data is going to cover quality, accessibility, and governance. If your data is inaccurate, siloed, or unmanaged, no amount of technology will save you. And finally, technology. This is where everyone wants to start, but it should actually come last. Are your systems modern enough? Do they talk to each other? Are you even using the right tools for the job? Here's the key insight. These 4 dimensions overlap. Most problems don't live in just one quadrant. A reporting issue might look like a technology problem, but the root cause could be data silos created by process gaps managed by untrained people. And you hear on that one, it crosses all of them. And remember this line. We've said it before, we'll keep saying it. You cannot automate a process you do not understand. That's the foundation everything else builds on. Now let's make it real with some examples. This table shows 4 common scenarios where organizations jump straight to a technology solution, and why that's almost always the wrong first move. Take the first one. Reports take 3 days to generate. The instinct is to throw AI at it. Automate the reporting. But when you actually diagnose the problem, you find that someone is manually pulling data from 5 different spreadsheets that don't even talk to each other. The right solution: centralize your data sources first. Then you can automate. The second example: slow customer response. Everyone says deploy a chatbot, but the real issue: your support team can't see the order history because the CRM and order system aren't integrated. Fix the plumbing first. Sales forecast constantly wrong? We need ML models. No, your sales team isn't even following a standard process. The classic data montage: garbage in, garbage out. Standardize your methodology, then layer in analytics. And data entry errors are going up on the last example. Before you add more validation rules, ask, did anyone train the staff on the new system? Sometimes the answer is a training program, not more technology. The pattern here is clear. Technology is rarely the first answer. Bad data creates bad predictions. Broken processes create broken automation. AI amplifies whatever is already there, so make sure what's there is worth amplifying. So what does all of this mean for the business analyst role? It's evolved significantly. Let's talk about 3 shifts that define the modern BA and agentic world. First, the 4 dimensions we talked about. Traditionally, business analysts focus on documenting requirements and translating between business and IT. That's necessary, but no longer sufficient. In an agentic world, you need to diagnose root causes across all 4 dimensions. the people, the process, the data, and the technology. If you look at only one, you'll miss the real problem. Second, the amplification effect. This is critical. AI doesn't create problems or solve them on its own. It amplifies whatever patterns already exist. If your processes are solid and your data is clean, AI accelerates your success. But what if the foundations are broken? AI just makes the failure faster and more expensive. Your job as an analyst is to evaluate which scenario you're walking into before anyone deploys the technology. Finally, strategic judgment. This is the new mandate. It's knowing when to recommend process improvement over automation, when to invest in training instead of buying yet another tool, when data governance should come before any dashboard project. Not every problem needs a technology solution, and the analyst who can make that call backed by diagnostic evidence becomes indispensable. Bottom line, if you master this 4-quadrant diagnostic framework, you become the person who ensures your organization solves the right problems the right way. That's the evolved business analyst. All right, now I'm going to turn it over to Rachel, who's going to get into the anatomy of business processes.
Awesome. Thank you, Mandi. So I want to talk a little bit about the mental model that I want everybody to walk away with at the end of this session. When we bring Azure and Fabric into a customer conversation, the instinct might be to invent a brand new end-to-end process for them in the business process catalog. And we want you to resist that. Azure and Fabric aren't a new value chain. They're the platform that the whole catalog runs on. So our anchor in the business process catalog is actually in the administer to operate end-to-end process, because that's the end-to-end that already owns IT operations, provisioning, security, compliance, business continuity, and support operations, just as a few examples. And everything on this slide, all the tiles that you see in between, are the anchors in between. So I want to talk about these tiles because each one is a real level 2 business process area inside of the administer to operate end-to-end process, not just something that we made up. And so I want to start with data. That's where Microsoft Fabric processes, or many Microsoft Fabric related processes, live. Think about the pipelines, the lakehouses, and the semantic models. When we think about monitoring systems, environments, and capacity, which is another L2 business process area, this is the home for tools like Azure Monitor and App Insights, where you can find telemetry, service health, and reliability tools. When we think about managing system access and security, this maps to Microsoft Entra and other Azure security tools that are available. If we look at defining business continuity plan, this is our BCDR story. Azure offers tools like Azure Backup and Site Recovery, just as a few examples, and business impact analysis, recovery objectives, and your disaster recovery testing. Support systems business process area covers the support procedures, subscriptions, and incident handling. That includes support with Microsoft, but also your own internal support processes that you may have technology needs for to support in your IT department, to support the systems that you use within your organization. The administer system features business process area is, I don't want to call it a dumping ground, but it is a little bit of a dumping ground for many different features that IT has to handle across the various technologies that an IT department might support to keep the lights on and running for the various technologies. This area is one that covers tenant configuration, governance control, landing zones, integrations, and so on. And the implement solutions is where you'll find many of our success by design processes and functionality, which, when you think about it, is the process of implementing a new technology. So even when you're implementing Azure or Fabric related products and services in your project and leveraging them, whether it's for Dynamics 365 or as a standalone, or with another technology solution that you might be implementing, the implement solutions area is where you'll find all of that, like success by design framework, and how we recommend that you implement a new technology solution. And our last tile, and one that I think is worth pausing on, and I think it's the bridge to the value chain tile, right? Every single one of our other 14 end-to-end processes end with a analyze area. And it's the last L2 area in each of those. So analyze financial performance inside of record to report, or analyze sales performance in order to cash, and so on. And this is where your platform work really starts to pay off. And I think when Fabric powers a financial close, as an example, the outcome traces to record to report. When it drives forecasting, it's forecast to plan. And when an Azure integration, moves fulfillment or procurement, then it's order to cash or source to pay. The analytics section is almost always where you'll find Fabric showing up in the value chain. And so here's how I would coach you and your teams to use the catalog. Start in administer to operate. Find the level 2 area that matches the platform work in front of you, whether that's data, monitoring, security, business continuity, or support. And then follow the outcome out to the value chain processes that it improves, and drop into that end-to-end analyze area to see the measurable result, and anchor that platform, map it to the product, and let the catalog point you to the related process instead of inventing a new one. All right. So one of the key principles that we teach in Success by Design is that you should start with problems, then processes, and then layer in technology. I think this is arguably one of the most important principles and key takeaways in our entire session. The reality, and this is something every Azure and Fabric implementation runs into, is that your workloads don't fit neatly into one service boundary. A cloud operations engagement is not just monitoring and resolving, support tickets. It touches resource governance, it touches security, it crosses into data operations. And when a pipeline failure is the root cause of an application incident, then real implementations span apps, data, infrastructure, security, and operations all at once. And yes, the catalog lets you filter by workload or service or product, and that is a useful starting point to get yourself oriented. But if you let that service boundary define your project scope, you may be missing the handoff and dependencies that matter most to the business to solve the problem. So the correct approach, and this connects directly to what Mandi talked about earlier about the modern business analyst, is to start with business problems. What's actually broken? what's costing the organization money, time, or trust, and map the processes that address those problems, and only then choose the right technology from Azure, Fabric, Dynamics, Microsoft 365, and the list goes on. Problems first, processes second, and then technology third. If you flip that order, you end up automating broken workflows or buying services that you don't need. Keep this principle in mind as we look at how individual processes are structured. So, on this slide, I want to talk a little bit about a framework that we use before we dive into some real world scenarios, and it's how do we actually define a business process? The framework that I want to talk about is called IDEF 0, which is the Integrated Definition for Function Modeling. And it's a structured way to break any process into 4 key elements. And I think this technique works really, really well for AI and agentic development. Every process has inputs on the left, the data that flows in, controls on the top, which are the rules and constraints that govern execution, outputs on the right, these are the results that are produced, and resources at the bottom, and these are the people and systems that do the work. So let me walk you through a concrete example. I'm going to queue these all up. Starting with inputs. When incident processes kick off, we need an Azure Monitor alert. That's the initial detection signal. We need application telemetry for context, what the service was doing when the alert fired, a service map or a configuration management database like a CMDB entry, so we know what depends on what. And a customer impact signal. Is this affecting end users or is it internal only issue? These inputs have to exist before the process can meaningfully start. Now, taking a closer look at the controls, these are those guardrails. We think about our service level objective or SLO or SLA and service level agreement targets. And define how fast you need to respond and resolve. We change policy, the change policy governs what approvals you need before you deploy a fix. And security and compliance rules constrain what you can do. You can't just SSH into production without controls. And escalation thresholds determine when this moves from a single engineer to a war room or a swarm, for example. Now, on the right-hand side are those outputs. When the process completes successfully, the incident record is updated and closed. A remediation action has been completed with the actual fix. And then the stakeholder status has been posted, and the leadership and effective teams know what happened. And then post-incident actions are created. These would be follow-up items, your retrospectives, and your runbook updates. And on the bottom are the resources. This is the who and what executes this process. So in this example of the resolving a service incident, we have the site reliability engineer or an SRE or an on-call engineer who owns the response. Azure Monitor and Defender are providing the observability layer, and so those are the technology resources that are being used. GitHub or Azure DevOps, which are other technologies that we use for change tracking and deployment. And then the runbooks and the knowledge base that codify what to do for known scenarios. And so these are like documents, for example, that you might house in a SharePoint. So this specific example of an IDEF 0 pattern applies to every business process in the catalog, whether it's resolving an incident, provisioning a landing zone, recovering a failed data pipeline, developing new extensions or solutions, right? Whatever it might be, when you're documenting or extending processes, always think about these 4 elements. All right. So reimagining some processes. Now that we've covered the anatomy and what processes look like, how they're structured, and where they map to Azure and Fabric capabilities, I want to get into the fun part. This is where we're going to reimagine a few processes and what happens when you apply this agentic mindset to a real world broken workflow. All right, so in our first example, this is a real life scenario for a company called Contoso Digital. It's a mid-sized enterprise with about 30 application teams that are running workloads across Azure. They've accumulated 6 different monitoring tools over the years: Azure Monitor, Datadog, PagerDuty, custom dashboards, you name it. Their goal is clear. They need to cut SEV2 or incident, high severity incident mean time to resolution to be below 30 minutes and reduce the number of repeat incidents. So if we follow this flow across the top, what happens is an alert fires, but it arrives with no context, just a threshold breach, no indication of what's actually happening or who's affected. So the on-call engineer starts a manual triage process. They're searching across 6 different tools, trying to piece together the picture. Then comes the runbook hunt. We're digging through a wiki with hundreds of pages, half of which are stale or contradictory. And next, they need to trace those dependencies. Is this an application issue? Is it a data pipeline issue? Or an infrastructure issue? And that's 3 different teams and 3 different tool sets. So they open tickets, but ownership is split. The app team says it's an infrastructure problem. The infrastructure team says it's a data problem. Nobody owns the resolution end to end. And eventually it escalates into a war room call. If we take a look at the pain points at the bottom, the owner is unclear from the start. 6 tools are checked manually. We have stale runbooks, a 3-team handoff before anything gets fixed, and the same types of incidents keep happening because the root cause was never properly addressed. This is the broken process. Now, let's take a look at what the business analyst uncovered underneath. So, there are 3 core findings from the discovery phase, and these mirror the exact kind of root cause analysis that Mandi walked through earlier. The first one is no unified context. Alerts, deployment, ownership, information, and the customer impact all were living in different tools. Engineers were spending the first 10 to 15 minutes of every incident just trying to assemble the picture before they even started diagnosing the problem. That's dead time in every single incident. Second is tribal knowledge rules. Senior engineers know which runbook to trust and which ones are outdated. They know who to call on each team, and new responders don't have any of that context. So they escalate earlier, involve more people, and it takes longer to resolve the same issues. Your incident response quality depends entirely on who happens to be on the call or be assigned to that particular issue. And third, the repeat incidents keep persisting. When incidents get resolved, the fix is documented after the fact, if it's documented at all. But similar signals aren't correlated across applications and environments. The same class of failure keeps happening because nobody connects the dots between an incident in app A on Tuesday and a nearly identical incident in app B on Thursday. And the business goal here, I think, is crisp, right? We need to reduce those severity to MTTRs to be mean time to resolution to below 30 minutes. Cut the repeat incidents by, say, 50%, and post a reliable stakeholder status within 10 minutes of detection. That's the target. So let me show you how agents can transform this operations process phase by phase. So here's this Azure operations process, like support operations example, laid out step by step. Across the top, we have the alert firing, we're correlating signals, identifying the owner, diagnosing the root cause, planning a fix, approving the change, and then closing the incident. So you'll notice that the process flow that we take here is solving the actual process first, from the original process flow that we looked at from the before. And in this first phase, right, it's all human effort. We're not changing the process itself. When we decide to start automating and augmenting this with AI, we're changing who performs each one of these steps or verbs. We want to keep the recipe, so to speak, and start to adjust the cook. So once we've got a well-defined process that we want to follow, in phase one, we can start agentifying, making up words, this entire process. And our recommendation is not to try to automate the entire incident lifecycle. Start with one capability. In this example, we're going to begin with Azure Monitor and Defender signal detection. Instead of alerts arriving with no context, you instrument proper detection, correlated signals, enriched alerts, and a severity classification based on the actual customer or employee, like internal impact. This one change means the on-call engineer starts their response with context instead of spending 15 minutes trying to build it out. Now, in phase two, this is where agents really start to enter the picture. We're going to introduce a site reliability agent. This agent correlates signals across your monitoring tools, identifies the likely owner based on service maps and your deployment history, and surfaces the relevant runbook, not the stale one, the one that actually matches this particular failure pattern. And it's using generative AI and LLMs and the rules that you define in your agent to help with this. The agent isn't replacing the engineer, it's assembling the context, suggesting next best actions, and updating the incident record in real time. The human still makes the diagnosis and plans the fix, but they're working with a complete picture from 1 minute in minute one instead of 15 minutes into that particular incident. And think about what this does immediately to your MTTR, minutes to resolution. If the first 15 minutes of every incident is just context assembly and the agent handles that automatically, you've already cut your response time dramatically. Now, in phase three, we want to layer in a change orchestration agent. And so once the engineer determines the fix, the agent can help handle that change workflow, notifying the affected teams, routing the approval, orchestrating the deployment through your existing CI/CD pipelines, and posting the stakeholder status. The engineer reviews and approves, and the agent is executing for them. And I think here's the compounding benefit. Oops. incidents are resolved, well, as incidents are resolved, the agents are correlating which signal patterns predict and which root causes repeat incidents start getting flagged before they escalate, because the system now connects signals across applications. We could also, right, if in this new process, later on in phase 4, you could start to add Fabric and other reporting to help automate that correlation automatically. Each phase builds on the last. We start with the foundation, get your signals right, then augment agents, assist the human, then orchestration agents help coordinate the response end to end. And I think that's the similar progression that Mandi introduced earlier in our presentation, applied to a concrete Azure operations scenario. So I want to switch gears now, and we're going to take a look at a completely different domain. In this example, we're going to do a Fabric analytics process. So in this example, Contoso Retail is running 12 data products sourced from 5 different systems. Their goal is to recover failed data refreshes in under 4 hours and improve data trust across the organization. So again, we're going to follow the process across the top. The data lands in the lakehouse on varied timing. Some sources refresh hourly, some daily, some are on demand. And when a pipeline fails, users are the ones who notice. They open a report, the numbers look wrong or stale. They ping the data team or the IT team on Teams, and the data team runs manual checks, jumping between notebooks, spreadsheets, pipeline logs to figure out what broke. Meanwhile, status updates are happening ad hoc. Someone posts in a Teams channel, someone else sends an email, and a third person has no idea there's even a problem. Then comes the metrics debate. 2 executives look at the same KPI and see different numbers because one dashboard pulls from a stale lakehouse table and the other hits a real-time stream. Nobody knows which source is authoritative. When we look at the pain points, the 2-day average recovery time when a pipeline fails, 5 source systems to check manually, no quality gates before data gets published, status communication is ad hoc, and metric definitions conflict across different teams. This is a trust problem masquerading as a data problem. Let's look at what the analyst uncovered underneath this broken process. There are 3 core findings from the discovery phase. First are quality issues that surface late. Problems aren't caught when data lands, they're found downstream when reports fail or when users question the numbers in a meeting. By then, a decision may have already been made on bad data. There are no quality dates, no validation checks, no automated profiling at the point of ingestion. The second signal is that ownership is unclear. When a metric looks wrong, the first question is always, whose table is this? Teams can't quickly trace which pipeline, which lakehouse table, or which data owner is responsible for a broken number. Lineage exists in theory, but it's not always operationalized. Nobody can follow the thread from a report cell back to the source systems in under 5 minutes. And the last signal that we heard is that we have these manual status loops. Data engineers are spending a significant portion of their week answering, is my data fresh questions on Teams instead of actually fixing pipelines and improving reliability. They've become a human status API. The business goal here is to recover failed refreshes in under 4 hours, publish trusted data products with clear ownership and quality scores, and notify impacted users before they make decisions on stale data. Let's now take a look at how AI and agents can help transform this business process. All right. So same basic pattern as the Azure operations example. We're going to start with a redesigned manual process across the top that's well designed. We're going to profile data, notify the owner, assess the impact, refresh the model, monitor health. Today, once we transform that business process, like every one of those steps is human effort. And you could implement this manually before you ever start to implement AI or automation on top of it. But let's start in phase one. In phase one, we're going to introduce a data quality agent. This agent profiles the incoming data at the point of ingestion. It's doing schema validation, row counts, checking for null rates, doing statistical distribution checks. And when something looks off, it doesn't wait for a user to notice a bad report. It flags the issue immediately, notifies the data owner, and in many cases can apply automated fixes, rerunning a pipeline, falling back to the latest known good state, or quarantining suspicious records before they propagate downstream. Now, in phase two, we're going to layer in what I'm going to call a lineage agent. When a quality issue is detected, the lineage agent traces the impact, which downstream tables, models, and report depend on the affected source. It surfaces the next best actions, which refreshes need to be rerun, which stakeholders need to be notified, and in what priority order. This eliminates the whose table is this anyways problem entirely. Then in phase three, we add what I'm calling an insight agent. This agent goes beyond fixing. It prepares, validates, and explains the data before publishing. When a data product is refreshed, the insight agent validates what key metrics are within expected ranges, generates plain language explanations of any significant changes, and publishes the data product with a confidence score. Consumers don't just see numbers, they see the context. And so the result, failed refreshes now get caught and recovered in hours instead of days. Data products ship with quality scores and lineage, and data engineers spend their time improving pipelines instead of answering, is my data fresh, on Teams or email. This is the same agentic progression, foundation, augmentation, and orchestration applied to a data lifecycle example. And just like the Azure operations example, it all starts with understanding the process before reaching for the technology. So that brings us to the resources and recommendations section of our presentation and wraps up what we wanted to talk about. We've pulled together a number of resources that you can use from the Microsoft Business Process Catalog, including links to our other Tech Talks, the catalog requests, how to request changes, how to actually download that. And if you do have questions, we encourage you to reach out to our team at bizprocessguides@microsoft.com. We invite you to stay tuned for the additional webinars and Tech Talks in our Tech Talk series. They happen on Thursdays. If you haven't already favorited our AKA link to the blog where we are posting the schedule and what's happening in our blog series, we invite you to do that. It's aka.ms/BPE Tech Talks blog. And with that, we do invite you to take a moment to fill out our survey. We'll make sure, if it's not already in our chat, we'll get this posted into the Q&A panel for you so you can click on it, but you can also scan that QR code or click the link on the slide to take a moment to fill out that survey. And we're going to open it up for questions. I do see that we have one question in the chat. one question I've been asked regarding the BPC is, can it be used for infrastructure only projects? i.e., a customer has SAP sitting on AWS, but a customer wants to keep SAC but change the infrastructure platform to Azure. Can the BPC be used for these types of projects? And I love that question. I think it's a fantastic question. And I think the short answer is yes, absolutely. So I think in this particular example, right, a big portion of this is going to literally be, in fact, probably all of it is going to be in the administer to operate end-to-end process. And so a big part, like anytime you're implementing anything, underneath administer to operate, there is a chunk called implement solutions. And I think like implement solutions is what you're doing anytime you implement Azure or Fabric. If you had like a Fabric only product and it was like SAP and you're just going to like layer on Fabric or Power BI on top of it, right? Even though it might be SAP or some other technology. It could be that you are just implementing some other completely third-party solution. You could also be in-house developing your own solution. So like as a partner, like if you're a software development company and you're developing a new solution that you're going to put out in the market, you can use the business process catalog for that as well. So I think in this particular example, it's primarily going to live inside of administer to operate L2 area called implement solutions. Obviously we don't have a lot of specific rows for SAP and AWS in our catalog, but you will find lots of rows for Azure in there already. So you might need to create new rows for your specific scenarios, but the level 1, 2, 3 should have like their product agnostic, and you should be able to find the business processes that you are executing already. So great question. Thank you for that. I don't see any other questions in the chat right now, unless Mandi, am I missing any?
Nope, that was the only one.
Great. Excellent. Well, since we don't have any more questions in the Q&A panel, I would like to thank everybody for joining us today. This concludes today's Tech Talk. And we hope to see you on our next Tech Talk. Bye, everyone.
Thank you.